Hello everyone. So today we are going to understand sliding window counter algorithm. So what does this algorithm do and how it works will be covered in this video with implementation. So let's deep dive. So what it is. So this algorithm combines the sliding window log and the fixed window counter approaches for more accurate and effective solutions. So we have different types or different ways in which the rate limiting is implemented. So one of which is a sliding window log and fixed window counters. In sliding window log, what does we do is we keep the queue and the queue will hold the timestamps at which the request arrived, and based on the maximum request which we have defined and the window size, it will eliminate the older request and try to satisfy the maximum request count which we have defined, which are coming at that particular moment. So if you want to understand that sliding window lock and the fixed window counter algorithm in deep, I have made a detailed video for both of them. I'll leave a link in the description. You can go and check that out. But in a nutshell, that is how the sliding window lock algorithm works. And a fixed window counter is nothing but the window is divided into, the time stamp is divided into, timeline is divided into fixed number of time slots. And we have per time slot fixed number of request, maximum request. If any user is making to our application server, that could be solved. And if number of requests from that particular user exceeds, we will eliminate those requests. So that is what how the fixed window counter works. And let's say when it passes that window, whatever window we have defined in that, it will reset is meaning like whatever the maximum request would be allowed by that user would be reset, and hence in that new window that user can make again that many max request count which we have defined for that to our application server. So that is how fixed window counter works. Now, both of this algorithm has its pros and cons. The new algorithm was invented, which is the sliding window counter. So here, instead of keeping track of every single request timestamp, as I mentioned, which sliding window log does, it focuses on the number of requests from the last window. Now, what does this mean? Focuses on number of requests from the last window. Let's understand that. So let's say our window started at t is equals to 1 second, and now we are at the mark of t is equals to 1.25 second. So we have moved in our window from 1 to 1.25 second. So that is 25% of our current window we have passed through. So here in this algorithm, how it works is, as we are at the mark of 25% in the current window, it will calculate what all request came at in that during period, like from 1 second to 1.25 second. And let's say our maximum count, like maximum request, maximum, when I say maximum count of the request to be satisfied, is nothing but a user making that maximum request in that time frame which we have defined to our application servers, right? Is some, let's say, x. So remaining amount of request, let's say out of this x, let's consider x as some three requests to be made, right? And at the mark of 25% the current window, let's say from time t is equals to 1 to 1.25 second, we got one request. And let's say consider we got two requests, right? Then the remaining one request we will be considering from the previous time frame which we defined. So that will be the 75% weight from the previous window plus the 25% of this current window would be taken into account. Now let's say if we are at the 50% mark of the current window, then from the previous window we'll take 50% weight. And let's say like, so if you can imagine, so it's like a sliding kind of a thing where we are considering the weights from current window and the previous windows. And as the current window grows, like we start proceeding in our current window, the weight from the previous window keeps on decreasing eventually. So we'll understand this in more detail in the upcoming example and the code walkthrough. So it will be very clear. So here there is a concept of weight. So hence weight, as I mentioned, that we are considering here the current window request as well as the last window request. So by what factor the last window request should be considered, like what percentage of last window request should be calculate, is nothing but 100 minus 25. Why 100 minus 25? Because 25% portion we are in the current window, so 75% will take it from the previous window, right? So that is 0.75 this will come out into number of last window requests. So we'll even keep track of the how many requests which we got in the last window plus the current window request, whatever we have got till that time period. So that wait at that particular time would be calculated in this fashion, right? We'll understand this in more detail in the example as well as in the code, so it will be very clear. But this is how it is currently implemented, sliding window counter algorithm. Now let's understand how does this work. Let's say we have an incoming request. So step one would be to track the request uh, count for the current and the previous window, right? So what does this meaning? What does this mean? Step one is nothing but we're keeping the track. So here also we'll also make sure that when we are as this is sliding window, so when we are surpassing the time frame which we have defined, the window time in seconds which we have defined. So let's say we are surpassing that. At that point, we will reset. So how the reset mechanism works here is like we are handling this in step one is what you right now can understand. We'll see in the code how the reset mechanism is implemented. But that is what we take care of in the step one. So that reset mechanism keep tracks of the previous and the current window counts, right? Now, what is the step two? As I mentioned, the weight. We calculate the weight as we saw in the previous formula, that is the portion of the or the percentage of the previous window request count plus the current window request count. That is nothing but calculating the weighted sum. Now, step three is once we have this weighted sum calculated, we'll check that is it within the limit. So everywhere the rate limiting which we have implemented all the five algorithms, we are making sure that we are rate limiting per user, right? So we will define maximum number of requests a user can make to our application server. Let's say that weighted some whatever value which we got is less than the limit, then we'll allow the request to be made and will increment the current window count for that particular user. If it is exceeding matlab greater than or equals to the limit, we'll reject the request. So this is the flow in which this algorithm works. Now let's understand this using a timeline diagram to be better to have better clarity over it. So here, let's say the maximum window request a user can the maximum request the user can make is, let's say we are defined as 3, and the maximum window size in seconds is, let's say we define as 1 second, right? So now let's say at time t is equals to 1 second, we got 2 requests from that user, both got satisfied, and we will allow that request because this is within our maximum request count which we have defined for a particular user. Now let's say time t is equals to 2 second, we got again 2 requests, right? Now both of this will be satisfied, right? Now as we progress, let's say time t is equals to 3 second mark, we got 3 requests. Now you will get it out that all of these 3 should get satisfied. But as I mentioned that we make sure that we are considering the weight from both of the windows, like from the previous window as well as the current window. So from the current window, 2 of the requests get satisfied and 1 request from the previous window would be considered, and hence the third request of this window would get rejected for now, right? So this is not exactly fixed window counter and this is not exactly sliding window lock. So it calculates based on the weight, and the weight is nothing but the percentage of the request from the previous window plus the current window, right? So this is how this algorithm works. And now let's understand the code walkthrough of the same. So as I previously also mentioned that this is also per user rate limiting. So we have rate limited for a particular user on the user basis, like every user will be rate limited when they are hitting the request or application server, right? I mean, in all of the algorithms which I've explained, I have made sure that we are rate limiting per user. Hence, two parameters, window size and second, defines the size of the window which we'll be defining, and the max request user can make in this window which we have defined. User request is nothing but per user will hold the request info. Request info is nothing but how many requests that user has made, what was this last, when the first request was made, and how many requests were made in the previous window, because here we also need to keep track of the previous window count, so that all the things will be hold under request info. And this is nothing but the constructor which where we will initialize this parameters. Now allow request is nothing but the core logic where we will decide that whether this user should be allowed, I mean request should be satisfied by, for like request should be satisfied for this user or not. So here first we'll calculate the current time, and we will check that whether this is the first time request from this user, or this user has made a request previously as well. So let's say if it's for the first time, then we'll go and create, I mean, this object holds all the information. So we'll see shortly what this object is holding. So we'll create that and set all the required parameters required. And let's say it's not for the first time. We'll try to get that information for that particular user. And the step one, which I was mentioning, right? So, which is this one. So let's say whatever the current time is, and whatever the request which was made by that user, like the current start, like when the first request was made, let's say if that exceeds our window size which we have defined. So let's say we had defined 1 second, so now it exceeded, so we need to reset the window, or we need to perform the reset operation for that particular user, right? This multiplying with 1000 is nothing but converting into milliseconds. So this is in seconds, and hence I'm converting to milliseconds, and these two parameters are already in milliseconds. So that is nothing but just conversion factor. And what does this reset do? Now let's see that, and also see what is this request info class holding. So that request info class itself has this functionality of reset. So request info is nothing but it's hold, this class object is hold for every user. I mean, any new user coming in will be holding this all information. So let's say we have current window start, like when the first request was made by that user, previous window count, and what is the current window count. So let's say when the request was made for the first time, this constructor will be called. We'll set the current window start as the current time at which the first request was hit to our application server, and this too will be set to 0. And let's say it was not for the first time. Then how the increment happens is something which we will handle here. But let's say it crossed the window frame which we have defined of 1 second, then the reset operation will be called for that particular user. So how resetting happens here is, so first thing is, whenever we are resetting, we'll try that, like what is the time passed. Time passed is nothing but, let's say whatever the request is made, the current time at which the request is arriving right now, and the when the first request was made, so we'll hold that in the current window start. So that will give us the time passed. Now let's say that and we also want to see that how many windows are getting passed, so hence we are first calculating the time passed. So this is the difference, nothing but the difference between the current time minus the first request made time, which is the current window start. So if we divide that with the per window whatever size which we have defined, which is 1 second, then we'll get number of windows, right? Now what is this logic actually? So let's understand this. So let's say we got request in the diagram as well, which I showed the timeline diagram. Let's see. Let's go. So here we got request as time t is equals to 2 second, and subsequently again at time t equals to 3 second we got the request. So here if you imagine, or if you think of, we can have two scenarios. Like we are getting like we are getting again the request from that user in the next window frame, which is the next start of the window, or else we are having some delay. Meaning, let's say at time t equals to 2 second we got the request, and after that there was no activity from that user, and for let's say 2 to 3 seconds, let's say 4 to 5 seconds, there was no activity, and the next request is coming at, let's say, some time t equals to 10 seconds. right? So there was a considerable amount of delay between those. Now now how in like in both the scenarios, how will the resetting take place is what I'll explain you in the code, and that is the reason where we have calculated the Windows past parameter to calculate this. I mean to handle this scenario. Let's go back to the code. The case where let's say window past was greater than 1, we are making the previous window count as 0, which is technically correct also. I think this makes sense that when it's like the next consecutive window, the previous count is nothing but the current window count. And let's say we have considerable amount of delay, all of this should get reset and hence we will make the previous window count as 0. But current window count would be every time 0 at the start of the new window or even after the delay. So that is what it is. And the current window start. Current window start is nothing but windows past into per window size. So let's say even if we were having delay, so we are not making the current window start as the current time, right? So let's say we got request as t is equals to 2 second, and then we got the next request at t equals to 8.5 seconds. So here we don't want to make our current window start as 8.5. We want to see that every window is like of 1 second, right? Then that doesn't make sense when we calculate the weight from the previous and the current window. If we make a current window again is at 8.5, even after the delay. So what we will do is we will see how many windows are getting passed. So if we take the difference, we will get 6 windows are getting passed, and every window of size 1 second. So 2 plus 6, which will be current window start will set as 8 seconds. So that is how this resetting logic is implemented and how we are calculating the weight. So weight is also very simple, the formula which I explained in that notes as well. So it is nothing but first, this is nothing but converting everything into milliseconds and time passed in window. So what time we have passed, how we'll get to know is nothing but current time minus current window start will give me the time passed in that particular window, right? What is the current time and how much time it got passed. And the weight is nothing but whatever window size we have defined minus the time passed in that window divided by window size in second. I mean, divided by the window size. So let's say now the current time, whatever we have got, minus the current window start. So definitely this counting of this weight happens once the window is reset. So this is nothing but to get the fraction of that percentage, right? And let's say we are at a mark of, I'll explain you with an example. Let's say we are at the mark of t equals to, understand it in a way that we are at the mark of, let's say t equals to 2.5 seconds, and we got a previous request or I mean current window start was let's say 2 seconds. So time passed is 0.5 seconds, right? So window size is 1 minus 1 second, 1, I mean 1 second, so 1 minus 0.5 divided by uh 1, so which is 0.5 is the weight, so which is nothing but 50% of the previous window is what we'll consider. That was it, and this is what I explained, that this is how the weight is getting calculated. Once we have this weighted count, so we will check that whether it is less than the maximum request per second per window. If it is, then we'll allow, otherwise we'll deny. Now let's understand and see how this is working. So in main, what I've made sure is when window size is nothing but 1 second, I've kept maximum request per window is what I've kept is 3. The timeline diagram, whatever I explained you, the same I've tried to simulate here. So first at time t equals to 0 or whatever timestamp we are hitting this, let's say 2 requests comes to our application server, both of that got satisfied. Then I have kept a delay of 1 second, right? After 1 second, I am hitting 3 more requests to my application server, each request coming at the delay of zero point 0.2 seconds, right? So technically, 2 should get satisfied from here and 1 should get rejected because still, I mean, after 1 second, we will be calculating the weight, which is 50% of the previous window, right? So two of them will get satisfied here and one will get rejected. So you can also calculate, I mean, you can try run this using this example and try to see how this is actually working. So now we'll go ahead. So if we see how the weight is getting calculated, so here the current time and the current window start will be same for the request which is coming here after a 1 second delay, right? I said subsequent request. So 0, 1, 2 request would be coming, three requests. The first request would be directly hitting, and after that the delays introduced. So here for that first request, the time passed in window would be 0 and the wait would be 1. The previous window count would be 2 because that was the count which was there before that 1 second delay, two requests we got. And the current window count right now is 0. So here, whatever is getting returned is 2, right? So when 2 gets returned here, it will check that is it less than max request per window, which is yes, and that request will get allowed, right? True. Now, after the next request comes in after 0.2 second delay. So then how the weight would get calculated is uh, the weight would be the current window start was 3, 3 minus 3.2. So zero point 0.2, right? Time passed in window is zero point 0.2. So this is, I consider this as one, I mean, this is all is in millisecond, but I'm just saying so that it becomes more easy to understand when I say like 1 minus zero point 0.2 divided by 1. So zero point 0.8 is the weight of the previous window count. So zero point 0.8 into 2 can consider like that. Zero point 0.8 into 2 is like 1.6 plus the current window count, which is 1. So which is 2.6. So I mean that will be still allowed because we are having the max request per window is 3. So that second request after 0.2 second delay gets allowed. And then the third request comes in. So when third request comes in, what happens here is zero point 0.4. Okay, 1 minus zero point 0.4, which will be zero point 0.6. And zero point 0.6 into point, zero point 0.6 into 2 would be zero point 0.6 into 2 would be how much? 6 to the 12. So 1.2 plus the current window count now is 2. So 1.2 plus 2, which will be something around 3 point something, which is not less than the 3, right? So that request will get denied off. And then again, we will have a delay of, let's say, a considerable amount of delay, the third scenario. All of both of this will get satisfied. Now let's run in this terminal and see how it is working. Yep, as I mentioned, both of these requests get satisfied. Two of this get satisfied after this 1 second delay, and this gets denied. You can also try run at your end to have a better clarity, but I even try run with you, so how it's working. So it's nothing but a simple maths, and this is after long delay, all of these three get satisfied. Now let's see the pros and cons of this algorithm. So it is more accurate than fixed window counter, definitely, and memory efficient than sliding window log. So in sliding window log, we used to log the timestamp at which the request arrived, right? So let's say in applications where the request, I mean, it is the read have whatever is the type of application where the number of requests made by the user is quite huge, then we need to hold all those timestamp, and hence it might lead to memory issues, right? So it is a good, effective way for this. Like we don't have to log the timestamps of each of the request, and it smooth out edges between the windows. Like as the fixed window counter had an issue that a user can maliciously try to satisfy more number of requests at the edges of the window if it tries to hit their application server at the edges, right? That also we have seen. And I mean, if you want to check that out, I'll leave the links in the description. You can go ahead and check that out. I've explained in detail how all these algorithms are working, so you can check that out in my chat on my channel as well. And even I'll drop links in the description. And this is the pros of this algorithm. What is its cons is like it is quite complex to implement, I would say. But yeah, we need to understand it. Once we are clear with understanding, it is not that difficult as well. So yeah, this was about the sliding window counter algorithm. I hope you like the content. If you like the content, do like, share, and subscribe, and follow for more. Let's meet in some other video with some other interesting tech related content. Till then, bye bye, take care, and have a nice day.